So I know we are late already, so I'll try to squeeze my presentation into the two, three key messages I want to leave to you today, and so that we can go and grab lunch. And if anybody has questions or curiosity or anything, we can have a chat over there. I'm Walter Rivera from Intel. I'm the AI technical lead for EMEA, and today I'm not here to talk about technology. I'm here more to talk about the hows, not the what. So, by raise of hand, how many of you knows what federated learning is? Please raise your hand if you are hearing this word for the first time in your life today. Federated learning. How many people have heard this word before? How many people didn't get the question? And how about RAG? RIAG. How many people are hearing these three letters together for the first time now? How many people have heard it before, apart from my colleagues? All right. Okay, great. I'll tell you what those two are. Today I'm here to talk about the critical marriage between the hardware and software. Yes, we can throw, power horses under the hood. The technology is there for sure. We've heard beautiful speeches before, but it really takes on the how we do things. You can't just throw horsepower if you don't know how to use them or what to do with them. And the Elon Musk example, it's a great example. He probably know what to do. Let me go very quickly. These are the challenges for AI today. It's 5 challenges: the complexity, the cost, operationalizing it. The last 2 are super important. They're not the last, but they are the foundation. So the human impact and the data privacy. So what is the future, the short and mid-term future telling us? There are 2 trends that we must watch. Guess what? The first one is federated learning. So I'll give you a gentle introduction to this. This is the picture of the world today. You have data centers and data silos next to them all over the places. You can think of this as hospitals, for example, or banks, or whatever office. And the big question is, let's assume that all the hospitals on the planet would love to build a model. For example, now COVID, fingers crossed, is part of the past. But let's assume we want to build a model that, taking a radiography of the chest, is able to tell you whether you have a COVID or not. I'm just making up a case here. It would be amazing if we could condense and leverage all the possible chest radiographies collected by all the hospitals of the world, wouldn't it? For sure, a model exposed to all that data would be irreplaceable. There's no human on the planet that could have been exposed to the same amount of medical information for that specific task. How do we do that? Practically speaking, okay? How would you do that? First, we have a big obstacle. It's called data regulation. But I love data regulation. I think it's great to have them. I mean, part of the EU, I'm Italian, so GDPR is definitely a thing, AI Act, and sorry to contradict a lot of technologists out there in LinkedIn, but I'm totally in favor of data regulations. Totally. I don't want my sensitive data to go all over the places so they can send me recommendation or whatever. But the critical point is we have a legal implication. Let's assume there's no data regulations at all. So all the hospitals can actually share the data, okay? Let's get rid of that obstacle. Again, how do you practically implement such training, the model? Do you send trucks full of SSDs to copy data from one hospital to another one, to centralize it in one location? If so, where is that one location? Who would be responsible for that? Are we building this on Mars so there's no, fight against countries? And the shame, you know what it is? This can apply to whatever application in the future. Huh? You know what is the shame? is that to build such an application, all we need is an AI model. State of the art is pretty mature for that. We need data and we need compute. So arguably, we have all the three ingredients to make the world a better place, but still we cannot bake that cake. Are we done? No. Federated learning is the answer to this problem. The way it works, let's see if it starts. Yeah. Imagine the three hospitals here, okay? You have A, B, and C. And each one has its own data. So they agree on one model, and they clone the model. Each one is training a copy of the model on its own data. Then the three models are sent back to an aggregation hub that fuses the model together and restarts. This is what we call horizontal federated learning. I've just completed a PhD on this subject. I was tall and blonde with blue eyes before starting it. So what you're seeing is the result of doing a PhD alongside my job. So I can tell you a lot of stories about this thing, if you're interested. But this is already reality. Intel has deployed this across 71 institutions worldwide, and the paper is public. You can apply this paradigm to whatever other market vector, into retail, into banks, into smart cities, into connected environment at home, where everyone needs to learn from the neighbor sensor. Now, if you look at this animation, there is an important aspect that is coming up. When the model, a local model, is communicated, you see the locker here? That's the data privacy and security. So AI is becoming more and more associated to security and data protection. You can't have one without thinking about the second. So if you're building your next step infrastructure, you must consider secure technology. Intel has done that, and we've embedded, this is the study I was mentioning before, with 71 clinical institutions all over the places, where you see the marker, it's countries that were involved in this study for, this was the brain tumor segmentation. We've embedded in the CPU, server CPU, no special SKU, it's just a normal product, normal CPU. Now it comes with two superpowers for security. One is called SGX, Software Guard Extension. The other is called TDX. Forget about these names, just think about one thing. It's trusted execution environment. Basically, you can have access in your own machine to a protected area which stays in memory. This is going to be vital, not only to protect data which are at rest. You know, you encrypt them, you forget them in the hard disk. No. This is vital to protect data and information while you're training your model, while you're doing stuff with it. Another big trend to watch, since we spoke about generative AI this morning, is that the industry is going this way and the academia is going that way. And academia, basically 2022, actually 2 years from now, in November, it was 2 years, that ChatGPT came out and suddenly the world realized, oh, there is an AI thing that does stuff. That's the tip of the iceberg. The experts already see that coming. But ChatGPT is not the only definition of AI. AI is such a bigger topic. And guess what? The paradox is that 2023 was the race to who's going to make an LLM bigger. 70 billion, 6 billion, 400 billion parameters. Now, that's what Meta has done with Llama. And 2024 is the rush for company and industry to who's going to make it smaller. And you know why? Because I find my company that sells shoes, for example, and I do have my store online, so you can buy shoes and you can return shoes if you don't like them or if it doesn't fit. I want you to interact with my chatbot. Well, guess what? I don't care if my chatbot doesn't know how to answer the question, what is the best carbonara recipe? I couldn't care less. All I need my chatbot to be able to do is to answer the question related to my work. So if you're a customer and you ask, hey, chatbot, tell me what is the best pizza recipe, I want my chatbot to tell you, sorry, I don't know how to make a pizza with my shoes. But if you ask, sorry, dear chatbot, what is the refund policy for the shoes when I return them? Here's your policy. This sounds like a funny example, but this has a huge implication on the infrastructure behind that. What are the reasons? This paper shows that an estimated cost of a ChatGPT query is 36 cents. Every time you ask, give me the recipe or play with it, that's the cost. If you're a company and you need to implement this service for yourself to expose outside or for your campus, whatever, this is not sustainable. And don't forget, the challenge is not only in building and putting the 1,000 GPUs that this morning was mentioned in the keynote. You need to cool that thing down. That's a lot of water. And you need to power that up. That's a lot of electricity. And I remember South Africa last year had, the time window when the electricity was on and when it was off. You need to keep that thing alive. So let's do things properly. Let's not just throw horsepower. And to do things properly, this is the RAG, which is the second question I asked you. Bear with me on the example of the shoes. We're going to find out why I mentioned that. Now, an LLM or Gen AI, you can replace this with Gen AI. Basically, you prompt something, you expect AI to answer. This works? Yes. For fun? Yes. But the knowledge of this LLM is frozen in time. You remember when ChatGPT came out, you would ask who won the latest World Cup? Football World Cup, and it was like 2 months before the ChatGPT came out. It couldn't answer. It didn't know. It might generate inaccurate answers. People like to call it hallucination. I hate that term, but it's just a mistake. What if not trained on a topic? What answer are you gonna get? Because this thing is gonna throw out words anyway, regardless. That's the job. And it's expensive to host. LLMs is a lot of parameters, means more memory, more compute. Some of the mistakes, well, this is just an example of how many M's are the word in weather. There's one M. Of course not. This happened in real life with Air Canada. Somebody asked the customer service, and the LLM said, oh, you are eligible for a refund because this happened to you. Guess what? It was completely made up by the LLM, but Air Canada had to pay the customer. So, and they, of course, shut down the service. So what is the solution? The solution is RAG. RAG stands for Retrieval Augmented Generation. So I will answer you, but I'll retrieve the answer from an augmented source of information. It could be a text file, it could be PDF, it could be a website, it could be a database, it could be images, it could be a video, whatever. The important thing is like having a kid that has just learned how to read and write, that you give the kid a book saying, look, study this book, whatever question you get asked for which the answer is in the book, provide that answer. If the answer is not in the book, say you don't know. Similar concept. What is hidden in this example I just mentioned of the kid and the book is that the knowledge stays fresh. As soon as you update the source of information, the kid has new information to provide. And it doesn't cost the amount of retraining a big model. It is very adherent to the source of knowledge, so it reduces the hallucinations, no Air Canada refund. Lack of knowledge can be prompted into no answer. And it's cheaper to deploy because you just need a kid. You do not need a super experienced professor which has seen the world inside out. This means a smaller language model is enough. Guess what? Small language model, 2-3 billion can fit in a laptop, as we were hearing before. We have recipes. I'm happy to, this is all public. We have GitHub repos to show you how you can build your RAG using the current infrastructure you have, squeeze the most out of it. I'm not going through all the single details. What is next? Well, you need to combine these two. So the world is not a gigantic digital brain that can do whatever. The world is a consolidation of smaller brains specialized in one thing. So more RAGs, smaller models specialized with source of information, which is more agile. And guess what? It has a less footprint on the requirement. Agents will be built on that. This is the full portfolio with Intel. In case you're going to have the slide afterwards, you can have a look at it. The Intel team is around, and I'm here. Yeah, we got a lot of nice. I'm going to skip through that. There is a question there. Yes. So what is the difference between a RAG source and a training data set? Okay. So if you had to train an LLM from scratch, depending on the size of the LLM, you need a lot of data. No surprise, the LLMs that are mostly commonly adopted today are ChatGPT. So OpenAI basically scraped the entire web. Meta with Llama. I mean, the source of data information that Meta has access to, I think is just not replicable. So you can, of course, train your own LLM and build your own data source, no props, but you're going to end up competing with those guys. So, and again, if we are doing this to do things better and in a more clever way, what's the point of reinventing the wheel? Let's start from a model which has been exposed to such knowledge, that has grasped all the basic knowledge. What we are doing with the RAG is basically specializing the ability of that model to address our private queries. So there is a little bit of retraining, if you will. Actually, there is this step. What you need to do, when I said the example of the kid, you give the book and the kid studies the question and answer. Technically speaking, is this block. This one. All the blue lane here starts from your private knowledge base, which could be your website, PDF, whatever. And we need to translate that into something that can be stored into a vector DB. So basically, from here to here, what we are doing is to go in through an embedding representation, which in other words means you take the words and you translate them into symbols, tokens. The model, when it will be queried by the user, will go there and say, this is the input, retrieve the embedding that is similar to my question, and retrieve the answer. That's how it works. It's basically a gigantic query system, a bit more clever. So you do not need to retrain the model. You just need to do these embedding steps where you're basically encoding your private information into something that goes into a vector DB. But that routine is way cheaper and faster than retraining a model. You're welcome. Any other question? Oof, I did it in less than 10 minutes. That's it. Thank you very much.